All right, good day, everybody. So we're still on our chemistry. So today we are going to be looking at writing and balancing chemical equation. So let's go to that slide where we have writing and balancing chemical equation. All right, writing and balancing chemical equation. Now, first of all, let's understand what a chemical equation is. Now we have here, what is a chemical equation? We have an expression of a chemical what reaction, an expression of a what chemical reaction using symbols and formula, an expression of a chemical reaction using symbols and formula. Now, in a chemical equation, we have two sides. We have the left hand side and we have the what? The right hand side. Now, as you can see here, this is the left hand side, this is the right hand side. Now, in the left hand side, we have A plus B, in which will now give us the product, the other side, the right hand side, which is C plus D. Now, this one that is in the left hand side, they are called the reactants. That is, they are the substances rather, that are reacting, that are being mixed together to form this other part, the right hand side, which is called the product side. So A is a reactant, B is a reactant. Why do we call it reactant? Because they are the one reacting with each other. They are the one being mixed together. Then we have C, a product, and D, a product. Why do we call them product? Because they are the one that are formed, okay, when you mix A and B together. Now, that's for chemical equation. Then we have a way of writing this chemical equation. Now, we have said that a chemical equation is what? An expression of a chemical reaction. An expression of a chemical reaction. So it means that in a chemical equation, we have different chemicals that are being mixed together to form another what? Chemical, which is a product. Is it not so? Good. Now, each of these chemicals that are being mixed together have a particular symbol with which they are represented, or have a particular formula with which they are what? Represented. Now, what's the difference between symbol and formula? Symbol is actually to represent a single element, while formula could be to represent a single element or a group of elements, otherwise known as what? Compound. Exactly. So now, when you want to write a chemical equation of a reaction, you take note of the symbol of each of the elements that are being mixed together. And after they are mixed together, the product that is formed, when you want to write out the product, you take note of what? The element, the symbol or the formula of the substance that is formed when those ones react. Okay? So now, balancing chemical equations. Now, we are all aware that there's a law called the law of what? Conservation of mass. The law of conservation of mass. Now, the law of conservation of mass is basically saying that if you have this element and this element mixing together, reactants, when you want to form a product or another substance based on the mixing of this element or the reacting of these elements in the reactant side, when you want to form a product, the product that you will form, the amount of the product that will be formed must be equal to the amount of reactants that were mixed together. That's why we say law of conservation of mass says energy can neither be created nor destroyed, but can be transformed from one form towards another. So, this reactant plus this reactant, when they form a product, transform from one form towards another, from the reactant form to the product form. When they form a product, what is here as a whole must be what will be here as a whole. That's the law of conservation of what? Mass. So now, balancing of chemical equation now comes in when you are trying to make sure that what we have on the left hand side is equal to what we have on the what? Right hand side. Now, what are the steps involved in balancing chemical equation? The first step is that write reactants and what? The products that is formed or produced. Write the reactant and the what product that is what produced. Okay, just normal, the simplest form. So after you have written it, the next thing you have to do now is to say, okay, I've written the reactant, I've written the product. You check how many atoms do we have in the reactant side, how many atoms do we have in the what product side. If the number of atoms in the product side is greater than the number of atoms in the reactant side, it means you need to go to the reactant side and increase the number of atoms so that it is now equal to the number of atoms you have in the what? Product side. If it happens that the number of atoms in the reactant side is greater, in this left hand side is greater, that means you come here and what? Make sure you increase the ones in this what product side so that it's equal to what the ones in the you have in the what reactant side. Now let's look at a typical example. Now we have an example here. NH3 plus O2 giving us NO plus H2O. Alright, so let's do some calculations. Let me get my marker. Where's my marker? Okay, let's see. Alright, here it is. So let's do some work. We have NO3, sorry, not NO3, we have NH3 rather, plus O2. Remember we said you write out the what? Reactant and the products. That's the first thing you do. So this is the normal equation. Now the next thing is to count the number of atoms that we have. Now if you check here, first of all, what are the elements that we have? We have nitrogen, we have hydrogen, we have oxygen on the reactant side. So this is the reactant side, and this is the product. So on the reactants, how many atoms of nitrogen do we have? It's just N, the root. So we have one nitrogen. Then how many atoms of hydrogen? We have three. Then oxygen we have what? Two. Now, let's come to the what? Product side. How many nitrogen do we have? We have one. How many oxygen? We have one here. Then we have another one here. And then we have two hydrogen. Now, if you look at this, you notice that nitrogen is one here, is one here. Okay. Now, oxygen here is two. Oxygen here is also two. Okay. But hydrogen is three here, but it's two here. Hydrogen is three here, is what? Is two here. So we need to balance the hydrogen. Now, how do we balance the hydrogen? If it is two here, then we need to increase the number here so that it will be equal to this. Exactly. Now, how do we increase the number here? We can decide to say, okay, what can I put here? Eh? Because we don't change any of the subscripts. Rather, to balance it, what we do is that we put a number in front of the word compound. Okay, we don't put a number as a subscript anywhere. When we want to balance the number of what atoms, we put it as a what in front of the compound. That is increase the number of moles. Okay, I've talked about moles before. So you increase the number of moles of the what substances. So now let's look at this. What will I do to this hydrogen here? Which number will I add here to increase the number of hydrogen here? Now, if I say I want to put 2 here, the hydrogen here will not be 4. That means I need to come and increase this one to what? 4, 2. And there's no way I can say, okay, if I add 1, put 2 here, this will be 6. Are you getting it now? So now what do we now do? Now let's use 3. If I put 3 here, 3 times 2, this one will not be 6. Now let's come here. I will put 2 here to make this one 6. That's fine. Now, if I do that, it means that whatever I put here is not just affecting this hydrogen, it's also affecting the what? Nitrogen. Okay? So, it means that this nitrogen will not be 2. I will now have to come here and increase this nitrogen to what? 2. Once I increase this nitrogen to 2, something also happens to this O. This O will not be 2 here. So, making it what? 3. And O here is 2. So, I will need to come here again. Okay? So, are you watching it now? Now, in order to balance this equation, what do I now do? I've given you an idea of how to do it now. So, what do I now do? I would put 6 here. The hydrogen here is now what? The hydrogen is now 12. We now have 12 hydrogen here. Okay? Now, I'll put 6 here, increasing it to 12 hydrogen. Now, when I come here, what do I do to this one? This is 3, right? 12 divided by 3 will give us what? 4. I will put 4 here. So 4 times 3 is 12. But this nitrogen is now 4. So nitrogen is now 4 here. I will now come here and put 4 here to balance this nitrogen. Now this oxygen is now what? How many? We have 4 times 1. We have 4 oxygen here. So this one is now 4 oxygen. This one is now 4 nitrogen. This one is what? How many oxygen? Now remember this 6 is affecting this one. So this one is now how many? 6 oxygen. So now automatically we have how many oxygen here? We have 4 plus what? 6. That's 10. But on this side we have how many? We have just 2. So 10 oxygen on this side divided by these 2 will give us what? 5. So we'll put 5 here. So for that, so that 5 times 2 is what? Is 10. So oxygen here is now what? 10 oxygen. Hydrogen here is now what? 12 hydrogen. And nitrogen here is now what? 4 nitrogen. See that it's now balanced. We have 4 nitrogen here, 4 nitrogen here. How many hydrogen do we have? 12 here, we have 12 here. We have how many, what do you call it? Oxygen, we have 10 here, we have 4 plus 6, 10. So the equation is what? Is balanced. Okay? It's pretty straightforward. So you can try out other questions on your own. And then if you have any questions, you can always ask. Thank you very much.